Okay, good morning student. Last time I have explained about the Cartesian product and the relation based on the Cartesian product and the subset of Cartesian product, that is called the relation. So relation is the subset of a Cartesian product which are related to each other, each elements. So now we will discuss the types of relation. Last time I have also explained universal relation or empty relation, identity relation. Now today we will discuss more about the relation equivalence relation. One of them, equivalence relation. A relation is said to be an equivalence relation if the relation is reflexive. So equivalence relation. What is the equivalence relation? How can we define equivalence? A relation is said to be an equivalence relation if the relation is a relation is said to be equivalence. Only three conditions there. First one is reflexive, second one is symmetric, and third one is the transitive. If the relation is follow the reflexive, symmetric, and transitive, then we say that a relation is said to be an equivalence relation. So one by one I will discuss now. First one is the reflexive. What type of relation reflexive? How can we define the reflexive? For all A belongs to A. Suppose that you have given the set A and we have select an element from set A. For all elements, whatever the elements in set A, if we select all elements, for all A belongs to A, all elements of set A, such that A belongs to R. It means every element is related to itself. That is called the reflexive relation, or A related to A. It means every element related to itself. Suppose that you have given the parallel lines, the relation between parallel lines like this 1, 2, 3, L, M, N. These are three lines and these are parallel to each other. So the relation between the line parallel is the reflexive relation, since every line is related parallel to itself also. Okay, this line is also parallel to itself, this line is also parallel to itself, this line is also parallel to angle. Every triangle, the similarity in the triangle. So every triangle is similar to itself. That is called the reflexive relation. So in example you can see that, example you can write relation is the set of parallel lines. So in example we can say that every line is the parallel to itself also. So that is the also a reflexive relation. Now second one is the given you symmetric relation. Symmetric means if for AB belongs to A, suppose that two elements. Reflexive is every element related to itself, only one element is need, but there is two elements. For A, B, two different elements that belongs to set A. A is another element and B is the second one. So A, B belong to A. If we take two elements from set A, and what the condition is there, if A, B belong to R and the relation A, B, the order, we make the order pair between A and B with the help of this relation, A, B belong to R, and also then if AB belong to R, then BA belong to R. If AB belongs to R, if AB belongs to R, then BA belongs to R, it means the relation is symmetric. Suppose that you have given that, you can write there example in this one, relation A is the set of similar triangles, you can say. A is the set of similar triangles. If example you can say, if triangle 1 is similar to triangle 2, it means we can write also triangle 2 similar to triangle 1, we can write also. So that is the symmetric. If first is similar to second one, then second one also a first one. It means AB belong to R, that is the, according to definition we can assume that is the A and that is the B. If AB, that is also a relation, that is a relation. Similar is the relation. similar triangles, and the relation is the similar. Relation क्या है? What the relation? Relation is similar. There is the relation parallel lines. There is the relation similar. The relation similar is the symmetric in the triangle. Yeah, among all triangles. A related to B. It means first triangle is similar to this one. We can assume that is the AB belong to R. That is follow the relation AB. Now we can convert their BA also belong to R. That is also a relation. Okay. Implies that AB belong to R and BA belong to R. That is called the symmetric. Transitive. In transitive relation, what can we say? A relation is said to be transitive for ABC. In transitive, we need to at least 3 elements. So, if for ABC, suppose that ABC is 3 elements that belongs to A. And also AB follow the relation one type relation, and BC also follow the same relation, and implies that AC belong to R. That is called the transitive relation. So example you can see. In this example you can see. In example, suppose that 4 is less than 5. Okay, suppose that A equal to B. 4 is less than 5 and 5 is less than 7. So you can see that is the A, that is B, and that is C. You assume that what is here? A equal to 4, B equal to 5 and C equal to 7. Or what the relation? Relation is greater than. What is the relation? Relation what is? Relation is greater than. The relation is greater than. That is the relation. There is the relation. 5 is greater than 4 and 7 is greater than 5. So what can we say? Implies that 7 is greater than 4 also. Okay. It means 7 is greater than 4. You can see that A less than B and B less than C implies that A less than C. Okay. In order pair we can say A, B belong to R and B, C belong to BC is the relation belong to R, implies that AC belong to R. That is the example of transitive relation. Is that clear? These are all about the equivalence relation. After that we have to come on the exercise 1. After exercise 1.1 we come to the next thing, that is the function. First we doing practice on the relation with the help of exercise 1.1. Check whether the following relation are symmetric. First is reflexive, symmetric and transitive. Okay, we check one by one. First one is, now do first one. What is the first one? Relation R on the set A. Relation R on the set A. What kind of say? A equal to 1, 2, 3 up to 14. 1, 2, 3 dot up to 14. And define R equal to. And what the relation define? How define the relation? R equal to xy is related to xy such that what is 3x minus y equal to 0. That is the relation given you. So in other words, you can say, first we check whether the following relations are reflexive, symmetric and transitive. We have to check all these three. So relations are on the set A. What the set has given? Only A set you have given. 1, 2, 3 up to 14. There are 14 elements in the set A, and the relations are defined on this set. It means we have to x and y, any one of them up to 1, from 1 to 14. X, y is any one of the elements. It may be 1, 2, 3, 4 up to 14. Not less than 1 and not greater than 14. These are all the positive integer. And what relation is there between x and y? How are they associated to each other? Y, 3x minus y equal to 0, or you can say it means y equal to 3x. You can say y is the 3 times of x. Y equal to 3 times of x. So we find out one. So what the relation we can find the relation if we put 1 here. It means multiple of 3. If we put y equal to 3x, okay, at x equal to 1, put x equal to 1, what will the y equal to 3 into 1, 3, x equal to 2. Accordingly, we have to take all values of x and all values of y should be contained in the set A, defined on the set A. So not any value taken from the outside A. So we have to take all values of x as well as y belonging to set A. So x equal to 2, then y equal to how much? 3 into 2, what will come? 6. If we take x equal to 3, what will y? Y equal to 3, 3 is 9. If we take x equal to 4, then y equal to 3 4 is 12. Okay, x equal to 5. So y equal to 3 into 5 equal to 15. You can observe 1 also from set A, 3 also from, that is also, it means that lie from set A. You can write 1 and 3. Okay, that is lie. These two values, both values of x and y containing in set A, lie in the set A. So 1, 3 is the relation that satisfies. Now the x equal to 2, it means x equal to 2, then what will the y? Y is equal to 6. 6 also, 2 and 6 both are lie in the set A. If taken x equal to 3, so what will the y? Y equal to 9. 9 also contain, you can see 1, 2, 3, 4 up to 14. 9 also, 3 also can lie in the set A. That is also lie. Now if taken x equal to 4, so what the value of y? You can say for 12. So 12 also lie in the set A. That is also a relation. If we take 5, so see that. If we take 5, what the value of 15? You can see that 15 is going outside from the set A. That cannot be under the relation. So we have to remove this one. After this, there is no any value, because after that we can go. If we take x equal to 5, after 4, 5, 6, 7, 8, y will also increase and going outside from the set A. That all values come after 14. That will not lie in our the set. So these are the relation according to this rule. Okay, this is the rule. So how can we say that? Check whether the following. Now you have to explain that is the symmetric, transitive or not. How can we? For symmetric we can say that first one A, or what can we write? R is R means relation. Relation is not symmetric, reflexive. R is not reflexive. Why? Since reflexive means every element is related to itself. So R is not reflexive since 1, 1, 2, 2, 3, 3 and etc. up to 14. These are not belong to set A. are not belongs to relation. Hence, so this is not a reflexive. So we can say that is not reflexive. Okay. Now come to the second B. For the symmetric, how can we say that it is symmetric or not? You can say 1 3 belongs to R, but 3 1 does not belong. So that is not a, only one element we can observe, other will also follow this same way. So 1 3 does not 1 3 belong to R, but 3 1 does not belongs to R. Hence it is not symmetric. Similarly, we can check the third one also. See, we can check C means symmetric. I have already explained, if AB belong to R and then BA also belong to R, BA must be belong to R for symmetric, but there is no any order pair or no any elements of the relation that follow the rules of symmetric. It means 1 3 3 1 also should be here, must be here. 2 6, if there are 2 6, then 6 2 must be here for symmetric, but there is no any or any element which follow the rule of symmetric. So this is not a symmetric relation. Come to the one transitive. So this is not a, R is not reflexive, and the R hence not a symmetric. Now come to a transitive. For transitive means ABC. For transitive we take 3 elements such that A, B, C. Then we can take any 3 or any 2 order pair. 1 3 belongs to R. You can see 1 3 belong to R, and the 3 after the another pair which start from 3 this one 1 3 belong to R, and 3 9 also belong to R, but according to the rule of transitive, A B belong to R, B C belong to R, then A C must be belong to R. But you can say that is the A B and that is the B C. You can observe A B belong to R, B C belong to R, but A C means 1 3. AC means 1 3, that is AC. 1 9. AC means 1 9 must be belong to R for transitive. So but 1 9 does not belong to R, hence it is not transitive. Okay, these are all about the question number first and part first. Similarly, you can observe one more thing. We can take one more question. What the second one is? Second one, relation R is given in such a way. What is the R x y y equal to x plus 5 x y such that y equal to x plus 5, and also given here, and what you given, and x less than 4 and x less than 4. Okay, for natural number. For which type? Natural number. Okay, so we have to check one by one. Similarly, just before we have done, similarly we can do here. But what the relation x y and x are related in this way, in such a way that y equal to x plus 5, and also x, what the values of x should be less than 4. It means, and the for natural number, all are defined for natural number. X or y, what type of number? There is natural number. So we can take, similarly, relation is given you y equal to x plus 5. That is the relation. Okay, so we can check how many elements will follow according to this rule. So y, if we take at x equal to 1, So y what be? Y equal to, in place of x, 1 plus 5, that is equal to 6. It means if we put 1, then we get 6. If we put x equal to 2, then y should be 2 plus 5. It means if we put 2, that means 7. X equal to 3, y equal to 3 plus 5. If we put 3, y will 8. 8. After that we cannot be go, because x is restricted by this rule, x should be less than 4. So we cannot go in the forward direction after the 3. Okay. So how many elements in the relation? So relation can be, you can write, this is the relation. We can write in the another form, that is in order pair 1 6 comma 2 7 comma and 3 8. This is the relation. And now we can explain, is the symmetric, reflexive or transitive. For symmetric, according to the definition of symmetric, every element is related to itself. So you can see that 1 2, how many elements? 1 2 3, and the 1 2 3 main elements of x, 1 2 3 and 6 7 8. So you can see, observe that, or we can observe that there is no such element from which we can say that 1 1 2 2 3 3 reflexive. What can we write here? Since 1, first one, or you can say A part, for symmetric, है ना? यानी कि since 1 1 2 2 3 3 3 3 does not lie in relation, hence it is not reflexive. Sorry, in the we are doing for reflexive. Since 1 1 2 2 3 3 does not lie in the relation, hence it is not reflexive. Is that clear? Okay. Come to the next one. For the symmetric, after symmetric we come, after reflexive we come or symmetric. For symmetric we can check symmetric. Symmetric means 1 6, if AB belong to R. What the definition of symmetric? If AB belong to R, then must be BA belong to R. Otherwise it will not symmetric. So we can observe only one element. What can we write? Since 1 6 belong to R, but 6 1 does not belong to R, hence it is not symmetric. Okay, it is not symmetric. Now see what the transitive. For transitive we can say if 1 6 belong to R and 6 1 or belong to R, and similarly other word. So we can do, since 1 6 belong to R and there is no second pair, so that can be defined. For the transitive must be, you can say for transitive what the condition? For transitive if AB belong to R and BC belong to R, implies that AC must belong to R. Okay, this is also a condition. And other condition also, if AB belong to R but there is no second pair is absent. So how can we define the third one? This is also a rule for transitive. If AB belong to R but BC is absent, you can see that BC is absent, so we can say there is no any AC, there is no another third pair or AC element that can be say that belong or not. So this is not a transitive. So once it belong to R, but other pair, other elements, you can say other elements but there is no such element that can be defined for transitive. Hence, if there is no other pair, so it is not transitive. Okay, hence it is not transitive. It is not transitive. Okay, in such a way we can explain all about the transitive, symmetric or reflexive. So question number 1, question number 2 I have done. Third, fourth, fifth you can do. So if you find any problem, if you have any problem, you can discuss with me. Either you can send me message for the problem, okay, so that we can describe in the next time. If you have any problem related to the question, related to the concept, give me the messages, or you can contact me on the comment box also, so that we can describe or we can explain about the. Okay, now come to the fifth one, fifth A part. R is given you x, y such that x and y work at the same place. X and y work at the same place. Okay. So we can say, how can we define x and y work at the same place? One by one I am making. First, for reflexive, we can say for reflexive, first one. Reflexive. For reflexive, you can say for reflexive. For reflexive, according to the definition of reflexive, every element of the set is related to all elements of element of the given set is related to itself. It means if x is the element, x and x belong to R. X and x is belong to R means x and x both are belong to R. It means a person and himself also both are belong to R. Both are doing a work at the same place. So we can say that it is reflexive. X and x work at the same place. A person and himself also. So that is the both are, we can define, and both are at the same place. X and x. It means what? It means x and x. And according x in place of y we put here x. X and x work at same place. So it is true. So we can say hence it is symmetric. Hence it is symmetric. Reflexive. For symmetric. No, for symmetric we can write, if you can see that x and y work at the same place, x and y work at same place. So it implies that we can say that in place of, we can interchange according to the definition of symmetric. If AB belong to R, then must be BA belong to R. Then BA must be belong to R. It means y and x work at the same place. Okay, you can see that if x and y work at the same place, then we can, other word we can say also y and x work at the same place. Both are same meaning and both rule are following the symmetric relation. Hence it is symmetric. It means, what this means? It means x, y belong to R implies that y, x also belong to R. Hence symmetric. Okay. Now third one for transitive. Transitive means if AB belong to R, BC and BC belong to R, then AC must belong to R. Otherwise that will not a transitive. So we can observe there, if x, y belong to R, what does it mean? X, y work at the same place. It means x, y work at the same place, and we have to take third element, y, z belong to R. It means then, and y, z also belong to, and R means y and z work at the same place. What does it mean? X, y work at the same place and y, z work at the same place. It means x, z work at the same place, means same place, work at the same place, that is the relation. Work at the same place, that is the relation. So we have to follow this rule for all reflexive, symmetric and transitive. X work at the same place, that will follow x and x also himself or herself. For symmetric, x, y work at the same place, we can say y, x also work at the same place. Third one, if x, y work at the same place and y, z work at the same place, and we according to a rule, so we can say that x, z must be work at the same place. So it means x, z belong to R. Hence it is transitive. It is transitive. Okay. So in this way we can say that reflexive, symmetric and transitive. Similarly, the other part of fifth question, first part, fifth question, A, B, C, that is the fifth A. You can do according to B, fifth B, fifth C, fifth D and fifth R, fifth E, sorry. So you can do in the A, B such that A less than B square. What we have to show? To show. What we have to show? We have to show that it is neither reflexive nor symmetric nor transitive. That neither reflexive symmetric nor transitive. Okay, neither reflexive nor symmetric or nor transitive. So how can we define? For neither, or you can say for negative sentence, we have to we can prove by giving one example. Okay, just do. First one is given you. Let example, first one for reflexive. If we take in place of a 1 by 2, suppose that a equal to 1 by 2. Let a equal to 1 by 2. So how can we define that this one is false? For neither means we have to prove that all are false. For false we have to take only example. With the help of any one example we can prove that will false. Okay, for the negative. So if we take a 1 by 2, so we follow the rule. In this is also a and there will also be a. So symmetric a less than a square. It means in place of a 1 by 2 less than 1 by 2 square implies that we can say 1 by 2 is less than 4. That is false. You can say that 1 by 4 is less than 1 by 2, but that is given, that's showing that 1 by 2 is less than 1 by 4. That is false. False. Hence not reflexive. Reflexive. Okay, for reflexive. Okay, reflexive. For symmetric. For negative we have to take such an example which cannot follow this rule. Which cannot follow this rule. Otherwise if you take integer that will follow. So we have to prove that is neither reflexive. In place of 1 by 2 if we take 1 and 2, you can say that 1 less than 2 less than 2, that is true. 2 less than 4, that is true. If you take positive integer, that is function is means r in the set. That function is defined for r. For real number, you can write here for real number. So we can take any real number. If we take positive integer, that will not make false. That will not make false. We have to take such example which can make false. So in this way we take a fractional number that will make false for this sentence. Okay, so we have to take on such a type example that can be make false for this statement. So we take 1 by 2. Now come to the second one, symmetric one. Second one is symmetric. So if we take 4 and 1, such example, we can take any real number or either you can take any. We have to take such example that can be make false this statement. If we take let a equal to 1 and b equal to 4 and b equal to 1. So okay, now we follow apply this rule. A less than b square. A less than b square imply we put these values. 1 less than 4 square, but and b less than a square. It means 4 less than 1 square implies that 4 less than 1, that is false. That is true. That is false. Okay. It means for the definition of symmetric, you can say if AB belong to R, then we have to interchange the order pair components. In place of B, we have to A and B we have to interchange for AB. According to the definition of symmetric, that if AB belong to R, then BA must be belong to R. So that I am in play. First we follow the AB for these two numbers. First we follow the AB, that is true. When we interchange this order component, so that will not follow the rule. That will false. Okay. So in this way we can say that is not a we can say that it means A, B belong to R, but B, A does not belong to R. Hence, it is not symmetric. Is that clear? Okay. Now come to the third. What is the third? Transitive. Transitive. Keep in mind, we have to take such example which can make false all these conditions. If they will make false, that will not reflexive. If they just make false, they will not symmetric. Similarly, we have to take such example that can make false for transitive. Okay. So how can we take this number? If we take A equal to 3, B equal to 2 and C equal to 1.5. Okay, you have to take such example according to this rule. And follow the rule. For transitive, you know that A, B belong to R. First one, transitive A less than B square. It means A less than B square means 2 square. Implies that 3 less than 4. True. Okay. What does mean? A, B belong to R. What does means? A, B belong to R. If we take another one, B, C. B less than C square. B means 2 less than C square. Okay, C square. So what will happen? 2 less than 15 square, 2.25. That is also true. Okay, true. It means BC belong to R. Now we can take for implies that CA, A less than C square. It means A, what the value of A? 2 less than C value, what the value of C? 1.5 whole square. A value 3. So what is mean? 3 less than 2.25. It means false. It means AC does not belong to R. Okay. So we have to take such examples that can make false all these three. So we can say that 3 less than 4, that is true. 2 less than 2.5, that is true. So AB belong to R, BC belong to R, but AC does not belong to R. So we can say that since AB belong to R and BC belong to R, but AC does not belong to R, so it is not transitive. Okay, these are all about the relation. On the base of this concept, you can do the exercise 1.1 and remaining question we can explain if you ask any one of them. Okay, next time I will